Okay, I'm starting. Okay, my name is Shafarik. You probably most of you already know me. I'm going to present the work we have been doing to do some cloud integration of Tomcat. A part of it is in Tomcat, a part of it is in some other repository. I have a bunch of demo. Last year I was demoing a small Raspberry cloud, but actually it's broken, so I'm not going to demo it. I should have it ready for Berlin. Basically, I've changed my Raspberry 3 by Raspberry 4, and then I need to rebuild the operating system and rebuild the OpenShift image, so it took a bit too much time. So basically, why do we need a cluster? In fact, when we speak about a cluster, we're going to replicate the session information. Session information that we need for the application. If we look to the cloud, we're going to have different problems compared to what we're running in a cluster of on your own hardware. Basically, in the cloud, you have some restriction. You don't have a multicast, so you're going to have a way to discover the other node. We have two providers. One which is named Dns Ping, which is going to use some Kubernetes internal API to find the next node, and another one which is Dns Ping, which uses the Kubernetes DNS to find the other nodes. What we have done is like you need to modify a bit the Tomcat cluster. This has been done as Remy was describing it in the state of the cat, basically explaining that we improve the clustering, and by improving this clustering, it's very easy to have another way of providing the member, which is how we are able to put these different cloud way of finding the member of our cluster. We have also to allow a dynamic list of nodes. Definitively, what you want in the cloud is like basically you want to be able to start and stop pods easily without noting it. In fact, basically you have you can if one pod start to hang, you can have a mechanism which is going to restart it automatically. I'm not going to go in this detail of demonstrating this. We have worked, so definitively you will see that it requires a lot of configuration. A big part of this configuration can be made a lot more easy because we can program it. We program it through an operator. Operator is a Kubernetes extension that allows you to basically define using the Kubernetes API, you can define the service route and things like that. So basically, we can very easily configure your application and to run it in the cloud. We have also prepared another thing with the S2I image. The S2I image is basically you have the source of your application somewhere, like in GitHub, and then you can have a mechanism which will build it automatically and put it in the cloud. And I hope to be able to run some demos. I spend a lot of time preparing them, but as you know, demo is always risky, but I have lots of some of stuff. And I have some room for what next, what you think about it, just basically that we can go on developing things. And that's the other one. So who I am, I'm working for Red Hat. I'm a Tomcat committer since a long time. I don't have the 20 plus for till December or something like that. So you can imagine. I'm a runner. If you want to join the morning run, just come tomorrow morning at 7 in the lobby. And I lived in Spain. I met my wife, which is my best supporter, and now living in Switzerland. No, I didn't press the wrong button. Okay, so why do we need session replication? Is basically because the protocol we are using, even if we are doing H2 or even H3, we will always at some point use HTTP 1.1 below the layers, and HTTP 1.1 have no transaction and no persistent connection. So in order to persist the information for the application, we will have to store the things in a cookie. So basically we are using a cookie to carry the session ID, and then definitively what happens is that the server will have to store the information the application is needing for the session. For example, the shopping star. Of course, if you want a session replication, well, we need a session replication because we will have a bunch of nodes, and we hope that the cluster is going to be dynamic. So we have usually a load balancer, which is clever enough, which is going to use the session ID and make sure that he is going to route the one session ID always to the same node, so that you prevent panic time exchanging information about the session. Because of course, if you balance from one node to the other, you will have to replicate the session, and you will have to wait until you receive the session. Sticky, yes. So you must know also that replicating the session will cost some resources. So basically, when you start to cluster your Tomcat, it's going to, your application will go a little slower because basically we'll have to replicate the information. And did I press the right one that time? No, definitely. Can't. Okay, so a cluster. So let's look a little what you have in a normal Tomcat cluster. So usually you are receiving your the thing from the internet through a kind of a filter. Then you can put something like HTTP as a front end, like you use mode proxy, for example. You will HTTP will know about the different Tomcat nodes, either by configuration, either by some dynamic mean, which could be configuring mode balancer in a dynamic way by sending it some request, or using something like mode cluster. And so basically, HTTP is aware of the different Tomcat, and is going to use a protocol, usually a TCP-based protocol, which will be a GP or HTTP or HTTPS or H2 to send data to the different Tomcat. The Tomcat have to communicate between them to send the session information, and this is this is other arrow. This is also going to use TCP/IP to exchange information between the Tomcat, the session information. The discovery, as I was telling before, in a normal cluster is done using multicast. You can also configure it dynamically if you want. So, can I go to the right one? Yes. So how to replicate session in your application? It's very easy. You just put distributable in the web.xml. You configure in server.xml that you want to use the cluster, and you use the sample TCP cluster. You restart Tomcat, and it's going to discover the other Tomcat which is running on your network. I'm not speaking about security in that case. You're supposed to secure your network before putting it putting it in the cluster. No? Kubernetes. So Kubernetes, there were a lot of development in the cloud in the past. You had Mesos, which didn't go very far. You had every kind of big software company was starting to do their own things, but at some point it's clear that Kubernetes is working everywhere. And for example, if you look to Amazon, they will have Kubernetes. If you like look to IBM, they have Kubernetes. If you to the Google Cloud Platform, they also have Kubernetes, and Azure also have Kubernetes. So basically, we all good. If you mention the Red Hat stuff, which is OpenShift, in fact, OpenShift is a layer above the things, and it can run of any of these physical clouds. So how you do a deployment in the cloud? Basically, the deployment in the cloud, you will have to build a Docker image. You have to push this Docker image to a registry, and you run a Docker container, and then you will have to expose your application. Basically, you expose it on port 80 of the cloud. So basically, the cloud is going to make all the routing things for you. Nope. I'll get accustomed to it. So it requires some automation, definitively, because the commands are going to be a bit different. If you use Amazon, you will have to use the console. You have its own interface, and then after some point you can use the standard Kubernetes command. On Azure, it's the same. You have to install your Azure client, you have Azure console, and use Docker, and then Kubernetes. IBM is going to move to OpenShift, so that's going to make my life a lot more easy. So I'm going to speak a little about OpenShift. I've borrowed those slides from my OpenShift colleague, so that's I will not. I don't want to go into detail, but OpenShift is just if it runs on OpenShift, it will run on Kubernetes. The thing is, like in some cases, it's a little bit more complex to configure in OpenShift in Kubernetes than in OpenShift, because basically OpenShift is preparing a bunch of things for you. So basically, if you run OpenShift, online, mostly you're going to use the Amazon cloud. And you can use the Amazon cloud directly if you want, and in this case you will use Kubernetes. So what do we have in a cloud? We're going to have a bunch of nodes. We're going to have a master node, which is going to basically, you can replicate it. This node is going basically to take care that the different nodes are running. In the nodes you have pods. For example, you can have a Tomcat running, but you could have also some other application running. So basically, what you're going to do is to start on your application. You're going to prepare it, and then you're going to run it on a pod. Usually, what the people are doing in the cloud is they run one application per pod, which is a lot more easy to configure, and then you will have to configure your application. If you have an application that is, if you need several applications, you will have to define a communication between them, somehow using REST, for example. So,
or gRPC.
Yeah, that's also possible. So if we look how it will work, it's like basically you write your application. You're going to compile your var with different methods that create a Docker image. This Docker image is going to start in a pod, and this pod is going to be replicated in the node. So basically, you're going to have something like, in this case, if you use OpenShift, you can use any of the different clouds that is below it. Bare metal means that you run your own stuff on your own infrastructure. Tell me if you don't hesitate to ask questions. I should be able to answer them. So how to get started with these things? So there's different ways. If you want to play with it, you can run it on your laptop by installing Minishift. It's easy. You can make a demo on a single box. Mostly the people demoing the cloud are, if the demo is not recorded, usually they will use Minishift. It's the best tool to basically demo the technology. You can have stuff online. The good thing, I've been using Katacoda. Katacoda is a very nice place where you can, usually you're supposed to write tutorial there, but it's a very good place to write demos too, and help people. For example, all my demos are also available on Katacoda, so you're going to be able to run them, crash them, and then complain to me so that I can fix them. That's a bit the goal. At some point it will work. The other thing is like you can have bare metal. Also, actually installing the cloud on a bunch of nodes is a kind of a pain. But luckily we use Ansible usually to install. In the case of OpenShift, you have a project named OpenShift Ansible, which allows you to install very easily on your own infrastructure. For example, in my office, I had some fun. I have a cluster of made by the old laptop we have in the office. Basically, I have 2 nodes, a master and an infra. An infra is basically the box which is going to store the images. The master is the one that controls the nodes and the infra. And the node is the place where you run the pod, basically where you're going to run your Tomcat. And I'm going to try to show a little, some detail how the things are working. So basically, we're going to move the guy on the top to what is below. So let's see a bit how we do it. So how you solve the problem? There's different. I'm going to explain the way we try to solve it, but there's also a way. You can use an embedded Tomcat in Spring Boot. Spring Boot will allow you to distribute the session, so we do it for you easily. You create a Docker image, or basically the cloud uses Docker mostly. So you can create your own image, or you just extend an existing one, which usually is the most easy. You can use Fabricate. Fabricate is going to allow you to create a Docker image very easily and get the stuff built in the cloud. The Tomcat is a replication, so of course we had 2 problems. We don't have multicast, so we need a kind of a ping to find the other node. So we have 2 ping, the QB ping and the DNS ping. In case you use the QB ping, you need to add the view node permission on your cloud configuration. And in the case of a DNS ping, you need to add a service which is going to provide the DNS for you.
Is that the liveness? Just to show it's alive?
Yes, you need to add some. You had also to add a live prop, which we have somewhere in Tomcat, which basically is going to tell that the node is alive, because otherwise Kubernetes is going to restart it.
Yeah, we have a very stupid health check valve, but the point is that also I talked about it in the new features. If you want a real health check like it's supposed to be, you have to use the Eclipse microprofile health. And so that's why I tried to add easier support for it. So
he's talking about here is node discovery.
Yes.
Right, I know.
So yes, of course you have.
But also in Kubernetes and OpenShift in general, you have those probes, the live probes.
Yes. I guess I don't know if I speak about it in more detail in another slide, but yes, you need it. So one of the solutions is the QB ping. Basically, we are replacing the multicast messages by each Tomcat is going to basically use the Kubernetes API. It's going to make a get to get the information. about the other nodes. So this looks something like that. So basically, you make a get. You get all the pods that are in the namespace that you are using, and basically that return a description of what you have. What we're interesting in there is like basically you're going to have the name. I think it's a bit small, sorry, but
It's okay. It's okay.
it's readable. You can have a look on the slide. So basically, it's written a lot of information, but we're interested in the name, of the of the pod and the IP address. And of course, we want some. We are going to filter that it's running in the logic because a Kubernetes API is going also to give us information about all the pods, and it can tell us that the pod is starting, and definitely we don't want to connect to a pod that is starting because it might not finish starting.
It's not ready.
It's not ready, so we are not going to be able to send stuff to it, so we will have error messages in the Catalina.log, which is something we try to avoid. I'm the right way. So basically, what we do in the code, we have a dynamic memberships server. We have a refresh thread, which is going to call the get member, and the member provider is going to provide a list of the member. And basically, it's going to get the URL, the sets, and all the environment variables it needs from Kubernetes to be able to make a SSL connection to the service, which is giving the list of the pod. Good for the time, or yes, should not run too fast. The DNS ping. So the DNS ping is basically we're going to replace the multicast by a get init get the get all by name of the namespace, and basically it's like a DNS lookup, and Kubernetes is going to reply with the information of the node. This is where the health check is quite important, because if you set the health check the correct way, it's going only to return the nodes that are already up. So that way you're sure you're not distributing to a dead node or a node which are not already started correctly. So a DNS lookup, it's very easy. I can this is I can show something like that very easily. I can do it. I have a small cloud running in my office, so I can edit what is on the things I should be able to show them. Is it readable? So this I'm connected to my cloud, which is basically 4 nodes in my office, and you
Maybe
can
one size larger, please.
yes, control
Control
plus, no?
should be.
Yes, it should work.
Try with shift, control shift plus.
Equal sign.
Yeah, because the plus is over the equal, so you need shift. Control
Yeah.
shift plus.
I'm not sure it works actually.
Control shift plus.
Yeah.
It doesn't. You can change the size.
Yeah, you have to configure it, but
Need another cable.
I thought it's. That's really
I don't do that that way.
forget
No.
it, forget it,
Okay,
forget
okay.
it.
I'm going to destroy it.
Never mind, it's okay.
Sorry, I don't. It's late. Sorry. So basically, what I did, I have my cloud running. I've logged to it using login, which you
Also login?
don't see it. It's okay, but
OC or SH, no?
yeah. So basically, yes, I do. The login must be somewhere up. I need to scroll the other way up. So I did the login to my cloud at some point. guess I should be able to scroll up. Did it? No, I need my mouse, which is on the table over there. Oops. Sorry.
You just turned it on.
Yeah, we'll turn it, yeah, from here.
Oh yeah, I can have a scroll. It would have been more easy. I won't screw it that way. So I should be able to scroll. So I did a login somewhere. I did a bunch of stuff.
Oh wait, no, look at that.
It was those in get namespaces or get projects.
No. I make also login at some point. So
Yeah, before you get the projects, right?
yeah.
Here
Yeah,
also.
well, I create the project before, but I'm just trying to show how the things work. No? So basically, here I have run the operator we have prepared, and then I'm just logging to my running machine. Don't worry, it's in the VPN of Red Hat, so you can't access to it. You need to hack my laptop first. So basically, you make it's a bit the same in Kubernetes. You make also a Kubernetes logging. Basically, you have the name of the master which is running, and then you have a token. So basically, you log into it, and in my case, I'm admin, so I'm going to can do whatever I want in my in my cloud. If you are using a public one, you can't be admin. You're going to have a standard user, so you're not going to be able to do all the things, but you're going to be able to start the Tomcat, and you're going to be able to start your operator. You're going to be able to start your nodes, and you can do the normally you can do so you make a get pod to have the pod, and if you want to look what one pod is doing, you have a in this case we have RSH, but in the case of Kubernetes, basically you're going to use one of the you are going to use the shell of that is running on that you are able to run on your Docker image, because basically you're going to start a Docker image, and basically you have an OS. Like if you have an Alpine, it's going to I guess you can use BusyBox, for example, and with BusyBox you have a shell, so you can connect to this shell, and in this shell you can do a bunch of commands. And for example, you do a NS lookup. In case I make a NS lookup for my namespace, which is a Tomcat demo, it's going to tell me the two Tomcat which are running, which are the two different.
So this command you write from within inside the pod, right?
Yes, I mean one of the pod. I can exit and enter the other pod and run the same command. I should have the same result. Maybe in a different order, but something like that. So this is Kubernetes development or OpenShift.
This is similar to Docker exec.
It's exactly Docker exec, but it's the syntax is a bit different, because it's the same. You have started your Docker image on the cloud, and then you connect to it and then execute a command. So in this case, we do a lookup, so we can see that we have two Tomcat pods running somewhere in the cloud, and then we will be able to distribute the session. So I'll return to the presentation. Thank you for the mouse. It's a lot more easy with the mouse.
So nice.
Yeah, it's better if it's near me. So where I was. So I think I moved to. So I can.
That one?
Yeah, this one. Well, this one I can also show, but on the screen you can't read anything. That's the issue. So this was the thing. So this is what I'm showing it. So yeah. So I'm going to show a little what we have on the code. The link clickable. I will make sure that in the demo you can access to it. So in Tomcat, under the Tomcat Maven, we have all the things you need to build your Docker image that you can use in the cloud. We have also prepared S2I image. We have a pull request to it. I will speak a little later on it. We have also created an operator. The operator is to make all the things you have to do by hand, which is basically you have to define your node, you have to add a service, you have to have a service to go outside, like a load balancer, and then you have to add a route. So all this can be done in an operator. In an operator, basically, you will just care about creating the number of nodes you have. I will run a short demo with it. Basically, I'm going to create the description of my node, of the number of replica I'm running, and then I should be able to reduce the number of replica running with one command and apply it.
Scale, right?
Sorry?
Scale?
Yes, I'll show it in the demo part. So this is the old. So I have. This is my old demo I was showing last year. I'm not going to show the detail of this one. I can do it if I have extra time later. So I have a new demo, which hopefully will work. So I need to find my Katacoda. Oops. I'm not very gifted in these things. So click on this, and of course it started somewhere else, I guess. I have it. You can see it's starting in the meantime, so that's why you don't wait. I'm just trying to move this to here, and here it is. So it's available. You don't run it now because at some point, if you run too many instances of the demo, it might not work very well. So you can see it's basically it needs to start the so it's using Kubernetes. It's going to start the Kubernetes. So it takes some time because basically I'm going to start a master and a node. That's the minimum you have in the. There's
For Kubernetes master.
yes.
So it's launching a Kubernetes cluster, which is
Exactly. That I've started the Kubernetes cluster in one of the Katacoda server. It had a master and a node, and on the node you can start several pods. This is what we're going to do. I'm going to jump over some things, but we can do some commands there, which I'm in a very wrong position to do it. I'm not very good in typing, so I'm going to. So, for example, you can get the node that has been started. There should be one node.
N instead of N. The typo.
Yeah, well, that's expected. I don't see what I'm typing. That's the issue.
Yeah, it doesn't tell.
Yes. I guess I can scroll. But
Git.
forgot that now.
Maybe don't use full screen on the browser.
Yeah. No, come on. I don't see what. Yeah, I need.
There's some cropping, yeah.
Yeah, some cropping for some reason.
Yeah, if you restore it instead of having full screen too.
Yeah, but it will still cut, I guess.
No, that, but then you can make it smaller.
You can make it smaller. I don't know.
No,
why.
but now if you scroll down all the way, it should show it, no? It will not cut it. If you scroll down all the way.
What it wants.
Yeah,
Okay,
now
yes.
you see. Yeah.
No, that's a.
Well, now the kubectl get notes, yeah.
You see, so I have one master running and one node running. So I can go on doing the demo, I can jump over some steps because I'm touching the key generator. And I'm not using it, so basically I need to check out some stuff which I've prepared before. So basically I have a small web demo which I need.
Oh, this is perfect for demo.
Yes, I'm not going to make any typo. Except I want to jump off.
I should have thought of it myself. But this is
So you see, you.
Yeah, Katakoda is excellent. You don't type, you just click on the command. It's
Yeah.
perfect.
So I'm going to build my demo with Maven, install it. It's like a while. Yeah, Maven is going to download the internet. That's normal. What do you expect? At some point, it's going to be done. At some point, I get the prompt back. Done. Good. Yeah. Ignore the mistyping. It's so I'm going to clone another repo where I have basically. So the idea is like basically here we're going to generate the image. I'm not going to do that because it's taking a lot more time and I have the image already generated. So basically it's a code which is in Tomcat Maven repo. You can get it. So basically, I'm making a Maven install. This is going to build the big jar. This big jar is going to be added to the Docker image. The Docker image, I'm sending it. I'm building it first, then I'm pushing it to my repo. And this I've already done before. So normally I can jump to the next part. So yeah, I have my other part of the demo. So I'll creating namespace. I'm creating the deployment. So I can create the Tomcat deployment. I'm creating the service.
process from scratch.
Yeah.
So we can create it. Yeah, hopefully it's good. I'm going to check what happens. So apparently it's running. It's look good. We should have started some pods. Yeah, we have a Tomcat. Pod running. So of course we have only one, so it's not going to show anything about session replication. So no problem. It has a Kubernetes command to scale it to 2, and if we redo the get pod, now we have to wait a little. It's not ready yet, but at some point it's going to be ready. Oh,
Yeah.
it's ready. Good. We can check the log. That's a bit complex because you need to. I'm not going to do it because I need to type this number, which I'm not very good. So I will surely fail it.
But time compilation works, no? Or in Katakoda?
Yeah, but it need to guess this number, which I can't. You can't copy paste easily. I would like copy paste this.
Yeah, but if you hit tab twice, I think it will complete it for you. And then you only have to have the first character of the last 5 characters are different. That's the only difference. It's okay.
It's a random number.
Yeah, it's
Yeah,
probably
that's
the
fine.
same thing here.
Yeah, but the thing I would have to. Additionally, I don't see. Why did I want? I want to show that I can run a shell on the thing and make the nice lookup. So here I have to put but I have to put this big number, which I don't think I have any
So
chance.
try tab twice. Try tab. Nothing?
Backspace.
No, so I won't do it
Maybe
because
because
I
it's in a
won't.
browser, it doesn't.
Yeah, I won't get it. So here the idea is like basically if I would have been able to type this big number, you would see what I have done before in my in the other slide where I do it on my own cluster where I can copy paste the things, because here it's in the browser, you can't copy paste. I guess Katacoda, they're going to improve their web handling, and at some point it's going to be able to copy paste. You can't copy from it, but you can paste stuff. But I have not figured out how I can get that in a file and send it to my laptop and then to basically copy paste it. I can try to type it in, but that would be difficult. We need to expose the deployment so that we can access to it. And if we get the service, we can see that the service has been started in Katacoda when it's pending in the time. So it had basically it's exposed this port, and it should have exposed my application on this port. So we can go. Usually we can go here.
Definitely, that creates the service and the route, right? The expose version.
Yes. That's going to make both, and then that's going to route it. So basically, here I have to remember the port number, which is
32138. 32138.
Exactly, which I have to type in here.
32138.
Exactly.
321
1 2
38.
38. Okay. 3 8. Good. So my display port, and then I should arrive to the Tomcat.
Yeah.
That was a Tomcat, yes?
Well, that's not too bad. Actually, I need to arrive to the application, so I guess if I put this, is this full?
32138.
Yes. 3 2 1 3 8.
Yes.
And then I need to type the URL of the demo, because of course I've started my demo, so it's demo. This I type it, and I have not put it to the root. I should. Yes, I should have installed it as a root application that it would have worked immediately. And normally I'm going to go on my server. Well, it's working. So normally if I refresh, it should increase the counter. You can see, and I should be able to kill
What?
I should be able to kill the pod. If I'm lucky, he's going to change the pod from time to time, so I can show you that it is.
Yeah, it changed.
Not two, right?
Yeah, it changed now.
It changed. So basically, it's working. So you have the. Have 10 minutes left? Cool. I can maybe demonstrate something else. So in case I would kill a pod, it will be restarted. The thing I have to type this huge number, so.
So
Can you scale it back to 1 and show us that it's still working?
Yes, this is easy. Because
I tried to give you an easy one.
Thank you.
thank you and pay you later.
So I can go to the terminal. I can. I don't know what I've run now, but.
Just do up arrow until you reach that and change to 1.
Yeah, but now-
Scroll down.
See you again.
Scroll down with the mouse scroll.
Yeah, but at the end, this is a bit stupid. Okay.
Are you in Zoom? Maybe you need, change to Zoom 100. Do Control 0. Maybe that's the problem.
You mean I can
Control
try?
0. No, because you're in Zoom in the browser. Maybe it doesn't know how to handle that. You see, you're 50% Zoom.
No, but I'm going to see the command now.
Okay.
You see?
Yeah, you need to find the scale to Replica 2, change it to 1.
So 1.
The main more interesting to do replicas for, instead of for.
Yeah, that would have been less risky. So I get the pod, must have the command somewhere,
Yeah, got it.
and there's only one running, and I go back here and I make refresh, and it should.
It needs to be
should still work.
RH6C7 and this one, same one.
Yeah!
Yay.
Woo! Oh, this works.
Definitely. So,
And if I scale it up, you should find more numbers.
which would be interesting, you want to do?
That's more easy, and that's more chance to work.
No, but that's everything is set up now. Just
Yes. Yeah, I just need to redo the command. So you're right. It should be super easy.
just up here a couple of times. Replicas 4 or something. Yeah.
At some point, Katakoda is going to throw me out because I'm going to need too many resources. So you can say, and if you check, get pods.
Yeah, that was a 4. One of them is ready.
Refresh.
Yeah, you need to wait a little more. Well, it needs some time to start them.
Yeah.
There you go. Running.
They're all running.
They are running, so
Now
if we,
let's go to the other tab.
if we go there, we should be able to see that it's going to another node.
Yeah.
4? Do you remember? Was it 4?
Yeah, it was 5, now 6. It's okay.
Yeah.
And the server was .1, now it's .4.
That's the same pod 7.
So
Okay,
it's-
that's a different pod 8.
Okay, so I'm not going to show that there's 4, but
No, but the counter is not replicated.
Got a bug.
that's not been.
You see, you have now 7, right?
Yes.
Hit reload. Hit reload and count how many times you reload. 8. Hit reload again, please. 9,
Same server.
10,
Different server.
11.
Yeah.
I can see it go down.
It went down earlier. That's the issue.
Well, there must be a small bug.
Okay.
Maybe
Mostly.
yeah. Well, the health check must report it's up while it does not have yet the access to the node.
Shared resource.
Right, so that's my question. How reliable is it that the session is replicated so you don't have a race condition
Well,
or something?
I need to fix it at the health check level because it's going to before telling that the node is up and before listing it as
it's the first get the session information and then be ready.
well, you need to make sure that the Tomcat is completely started. And I guess actually the health check is returning okay because
Before it's ready.
before it's ready. And it's very easy because I think it's a sample filter, but I can put there a valve, and in the valve I can check that I have access to the rest of the node. So this is there's a small
Very
bug to
cool.
fix.
It's also
Yeah.
possible to make requests faster than the replication occurs.
Yeah, that's my question.
Yes.
If you hit F5 now.
Normally it's
it
just a question of writing your application that it wait until the
No,
replication
no,
has
but
occurred.
Two nodes can get it.
No. With session replication, you're always supposed to use sticky sessions, otherwise it will never work.
Right.
It works. It's in the servlet API actually. You can't make concurrent access to the same session on different nodes in a cluster. It's not possible.
Well, you can.
No,
It
you
would just be a
can't.
problem.
It's forbidden by the servlet
Yeah.
API. All the concurrent requests must go to a single node.
But practically, it
No,
you
it's
can't really
mandatory.
enforce that.
It's
I know it's
mandatory.
mandatory, but it's not possible to enforce.
Well,
You can't have a
you
single
can-
cluster.
you
You can't have
can-
a cluster-wise synchronous
you can-
clock.
you have to use sticky sessions, in
But
which case you won't
you
have
can-
the problem.
But why don't we have like
Wow.
a session server that just maintains,
Right.
instead of replicating all the time all the sessions to all of them,
And then you still have a single point.
it's like a cache server, like
We do.
Redis.
You can use Redis. You can use Memcache.
Yes.
Is it right now, or you need
Yeah.
to build your own
It's not.
session?
It's,
Yes, you
it
add it
doesn't
on
come with
top, but
Tomcat,
that's
but
a-
you can get a session manager from GitHub or something. They exist.
Why don't
But-
we have in Tomcat?
Because we don't want to have external dependencies.
And you can change the code and make sure that your session is replicated before returning the request.
Mhm.
But you still have a race condition with Memcache.
Yep. Always.
You hit two servers at the same time, which one wins?
Well,
the
yeah.
last one. That's the one who wins.
Well, obviously the node is coming is saying that it's a bit too early.
No, you need to
Still
think it through and plan it properly, of course. It's not.
No,
I have a question though about when I tried to run Tomcat in OpenShift, I ran into security issues, which didn't happen in Kubernetes. You don't have this problem, same problem, but OpenShift is more strict.
Yes, depend on the version of Kubernetes you're running. They have been improving the security, and then you have to configure it in order to be able to get it running. Especially if you are online.
Yeah.
If you are using OpenShift online, some of you are a basic user, so for Kubernetes, so basically you can't configure it to access to the other pod. You're going to have some security problem. Yes.
Do you have any suggestions for good monitoring, tracing tools for the cloud? Because it's very difficult now to troubleshoot when there's a problem, right? When it's running in Kubernetes or in OpenShift.
You need to use, for example, Jolokia and Prometheus, which will tell you if something goes wrong. And then you need to do what I've been doing, like access to the node that it seems to be hanging or before it's restarted.
Your application needs to be so intelligent just to start filling up all the Jolokia and Prometheus, and then you can
Yeah,
get
and
Yes.
you can also we can also add something to basically send the Catalina node out to a common logging thing. Basically, you need to reformat it and then send it to something like Iaga
And
that you have running in the cloud.
One more quick question: why do you recommend Spring Boot? Why is Spring Boot and not?
Someone had suggest the stuff. I've seen it running, so this is
But
why.
what's the benefit? What does Spring Boot bring that you don't have with just Tomcat?
It brings the session replication by itself. They have a
Oh.
module to do that.
Okay.
I have seen it running. I have not tested it. I've seen a demo, like a demo I'm doing.
So you talked about a centralized logging for Catalina. Now, if your application is doing its own level logging, you need to configure the application level to go to a centralized logging system.
Yes, that's something we will have to add. Yes.
Yeah.
Actually, you will use Yaga that will collect this information.
Okay.
And we need to use like open traces.
Yeah. But that's something that need to be added because that's need a JSON format which we don't have. We have a text. Actually, I think on my cluster running in the office, I can show the log because the log you can access for each pod. You can access to the log because it goes to standard out, and this is accessible directly in OpenShift or in Kubernetes. But
It's
that's
also get logs, no? There is a
yeah, you can
It's
make a
okay,
get log.
okay.
Yeah, you can make a get log on one of the pods. The thing I have to type,
No, it's okay.
I will show it.
I know you need to type the ID.
No, but I can show it on my server in the office.
It's okay.
Good.
I'm done, but if you want to stay, I can show you the get log.
All right, thank you.